Hey everyone, welcome to our Section 1 review. We're going to be covering modules 1, 3, and 4. I've already pulled the class to see which questions you want to cover, so we'll get into it. Keep in mind comparative and absolute advantage are at the end, so you'll kind of have to stick around or just fast forward to the end to where we start getting into it. So let's go ahead and get into it. The first question we wanted to cover was 3. So we have Zoe's grandparents are excited about finally paying off their mortgage because they say, our cost of housing is 0. Zoe should explain to them the economic concept of, well, this one means they're clearly forgetting the idea of what? Opportunity cost. Because every day they spend in that house is income that they could have earned from, well, what could you guys do with a house? You could sell it, you could rent it. So there's always an opportunity cost. So the key here will be opportunity cost, and well, there it is. It says by living in a house, they're giving out the opportunity cost to sell the house, buy a small one, pocket the difference, rent, so on. Does that make sense? And if you're like, I still don't understand why D is correct, say something. Like, why is it not D? I can go over that too. But we're good there? Or? Okay, cool. We'll move on down to 7. Which of the following statement is normative? Normative, remember normative, normal. What is normal? Subjective. So what's a subjective statement? Kind of look for the word should is often like a hint. So it says women's labor force participation has increased in the past 100 years. Can you be positive that is true or not? Yes, that's measurable. All right, the federal minimum wage is higher today than it was in 1990. Can that be absolutely true? Can you be positive it's true or not? Yes, positive statement. Children in the United States are required to go to school until they reach a certain age. Ooh, is that provable? Yes, you can say that is true or not. The best way of, subjective. The best way to encourage growth in the economy is through government spending. That is subjective, that is normative. Is that good? Any questions? All right, we will mosey on to number 10. All right, number 10. Madeline's teacher has assigned a research paper on any topic in microeconomics. An appropriate topic for Madeline's paper might be, so this is really asking, is this about microeconomics? The definition of microeconomics is a study of how firms and households interact in markets. That's a good definition to have in the future and stuff. So it's not macroeconomics, which is the economy as a whole. So unemployment in the United States since 1950. Unemployment is a macro topic. The impact of inflation, the price level of all goods, macro topic. Central bank, right there, monetary policy, central bank, our central bank in the US is called the Federal Reserve. That is an economy as a whole type thing, macro. There's a connection between fiscal policy and the election cycle. Fiscal policy is spending by the government to influence the entire economy, macro. The impact of rising gasoline prices on the sales of sport utility vehicles. Micro talks about markets, and that's a market for a single good like gasoline, or the market for a single good like, what did they say, sport utility vehicles. That's micro. Does that make sense, everyone? So micro is like a single type of good, or maybe two goods relating to each other. Macro is all the goods and services, all the labor, all the price levels in an economy.
But for gasoline, doesn't it change like all throughout the states?
So gasoline, I wouldn't say gasoline, I would say energy prices or oil prices. That can be a macro topic only for something we call cost push inflation, aka stagflation. But gasoline prices, yes, that can be the gasoline in all the country, but how many goods are we discussing? Micro. Now if we talk about what about prices in the whole country of everything, macro. So it's a single good, almost certainly micro. That help? All right. And unemployment, we can talk about unemployment in micro, but it would be for like butchers, a single profession, or people who work at a single factory. So we'll talk about markets, not the entire unemployment rate of the whole country. Okay, oh, we are smoking along now. So the next one we'll cover is 15. All right, 15. The economy's factors of production are not equally suitable for producing different types of goods. This principle generates Oh, okay, this is a good one. So if our factors of production are not equally good, this is something I kind of got to in some of the classes and wasn't able to. Remember we talked about cakes and cupcakes? We said all the land, labor, and capital for producing cupcakes is the same for producing cakes. Does that make sense to you guys? Like think of the land, labor, and capital of making cupcakes. How different is it from making cakes? So it would be a proportional amount. Make sense? That means there's no specialization at all. And the PPF for that would be a straight line. A bowed out curve, the PPFs that we saw at the beginning of class, that bends, bowed out, that shows specialization because some resources are better at some goods and some resources are better at others. Does that make sense? Guns and butter? Not all the land, labor, and capital for butter is that good for making guns. Meaning if we let people specialize to what they're best at, you can actually get more and our curve goes outward. Does that make sense? What that though creates is something called increasing opportunity cost. It means the slope of the PPF changes at every step. It's not a straight line. It gets steeper, meaning you give up less at the beginning. Remember we said if we had like gunsmiths and we had like dairy farmers, at the beginning where I take the dairy farmers and I say, go make butter instead of just making guns, I'll get a lot of butter and lose how many guns? Very few. Does that make sense? But what happens when I keep moving people to making butter and I take my gunsmiths and I say, go make butter? Well, how much butter are my gunsmiths gonna make? Not much. However, how many guns will we lose then? A lot. Remember at the beginning, few guns for a lot of butter, and then all of a sudden we get a little butter for a lot of guns. Our cost of butter increased because the slope of our curve increased too. Does that make sense? In short, let's look at this question. We know that if there is specialization, as in the economy's factors are not equally suitable for producing different types of goods, this would create what problem? Or phenomenon, really? It would be an increasing opportunity cost. Specialization means you have increasing opportunity costs because that curve is bowed out. Make sense? But it was cakes and cupcakes. If I took a few bakers and kitchens and said, go make some cakes, there's 12 cupcakes. And when I did the next sign, 12 cupcakes per one cake. 12 to 1, 12 to 1, straight line, slope. Does that make sense to you guys? Get an interesting vibe of maybe I kind of get it. But ask if you don't, and I can clarify. Is that good then? So it's a kind of simple question, but a bigger concept that we didn't quite get to. All right, 17 then? All right. Suppose the state of Texoma decides to produce only two goods, oil and football helmets, okay? According to the production possibilities curve, as oil production increases, the production of football helmets will, okay. They're asking you to understand a few things. Oil and football helmets, how related are those goods? Think of the land, labor, and capital to produce oil. Now think of the land, labor, and capital to make football helmets. How similar are they? They're not, meaning what exists? Specialization. That curve would bend outward, meaning the opportunity cost must do what? Increase as you make more of a good. Guys seeing that kind of logical step? So, it says the production of football helmets will, according to production, as oil production increases, the production of football helmets will what? Oh yeah, it would just be decreasing, okay. Well, there you go. We didn't have to go that deep, sorry. Easy enough?
So if the two products were similar in resources, what would happen?
It would still be decrease. It should be decrease at an increasing rate, but decrease is gonna be good enough because there's no other decrease. Anyways, that makes sense? Sorry, I thought they'd have decrease at an increasing rate, and then I read the rest of it. Okay, we're good? 22? All right. Ooh, table, nice. All right, study and leisure. Man, we are going to get into work and leisure like next quarter. Be deep stuff. This will be easy. A student sleeps 8 hours per day and divides the remaining time between study time and leisure time. The table shows the combinations of study and leisure time that can be produced in the 16 waking hours each day. Suppose a student completes a speed reading course that allows him to do the same amount of studying in half as many hours. Which of the following is now true of his opportunity cost? Okay? This is a tricky wording, and you really got to kind of see it or draw it out. So, this is before the speed reading course, okay? But now, you can do twice as much reading in the same hour, or in 1 hour or in half the time. So, that means what happens to the opportunity cost? So that gives them more time of leisure. But what it does is, what does it do to every hour of leisure? Does it make each hour of leisure more expensive or cheaper?
Cheaper.
More expensive. Okay, ready? Think about it in pages of studying. Let's say in an hour you can study 10 pages, but now you can study 20 pages in an hour. Which is more valuable, studying 20 pages or 10 pages? 20 pages. Does that make sense, everyone? You get more out of it? But now, that means every hour of leisure, instead of giving up 10 pages, what do you have to give up? 20 pages. Meaning that hour of leisure is now more what? Expensive. You have to give up more reading pages for every hour of leisure. Make sense? Now's a good time to ask questions. Yeah.
So in the question, they're not cutting the hours of studying? They're doing
You
the
can,
same
remember,
studying.
you can have 0 to 16. We're talking about value. And this question is, students always have trouble with it because it's like, you think of studying being completed. But when you get into college, you find out that that's not possible. You just go, you do marginal analysis. We'll get to that later. But essentially, if you have this much reading, well, that means every hour of leisure, I'm giving myself, future me, more reading to do. So it's more expensive every hour of leisure. The cost of leisure has gone up. Does that make sense to you guys? If you want to change the wording and the concept, you can think of it as you're a factory making, cupcakes. Now you make your cupcakes twice as fast. But every hour off means you make less cupcakes, you'd sell less cupcakes, and you make less money out of it. Does that make sense? Is that like a better one? So it's that idea. If I'm better at one thing, every hour of doing the other thing is more expensive because now I'm giving up twice as much output. Okay, now, keep asking questions if you're still like, I don't get it, but tell me what you're not understanding or why not this.
Okay, so when I first read the problem, I assumed that they wanted to do the same amount of studying, but it was only taking half the time. But that would be inefficient, correct?
That's a normative state. It's not necessarily efficient or not. It depends on what you need to do. And it's not asking, is that efficient? It's saying what happens to the cost of leisure. The cost of leisure increases. That's why this one's odd. You have to think like an economist, right? You guys good? Any questions? Now's a good time to get it. There's questions similar to this kind of stuff. We're good? All right, cool. All right, we'll move on to the next one. Oh, yeah, okay. If a production possibilities curve is a straight line, it tells us that the opportunity cost of producing one more unit of good X. Well, what do we know about the opportunity cost? Straight line, it must be, the opportunity cost must be constant. It would be slope. Remember cakes and cupcakes? 12 to 1, 12 to 1, 12 to 1, 12 to 1. So if we look at that, it means it must be constant amount of good wine. Does that check out? Are you sure? Okay. So we skipped that whole page, sweet, and we're going to 31. Good group. All right. Oh, we covered this class. High school graduate who gets a college degree is adding to the economy stock of human capital. Could you make an argument? Labor? Sure, but then everyone would be. But a better answer is human capital. Education is part of human capital. All good? Easy one. I'll move on to 35. All right. A nation produces goods X and Y. All right. Suppose a technological process has increased the production of good X by 50% and increased production of good Y by 40%. All right, I covered this a little bit in like 2 of the periods. Do you guys remember when I covered economic growth? And I mentioned that it doesn't have to always be symmetrical growth. You can have asymmetrical growth where a new thing is added to the economy, helping produce one good, but maybe even not even changing how well you can produce the other. You guys kind of remember that? Okay, or maybe not. So we're getting better at good X, but less better of good Y. Does that make sense? Okay. Assuming that good X is plotted on the X-axis and Y is on the Y-axis, we can conclude that, what does the slope do? Okay, let me just walk through how I would solve this one, okay? So this kind of there are better ways to think of it, but to me, the best way is to just, when in doubt, graph it out, okay? So I have good X and good Y, and we'll assume a straight line because it says no speciality. Make sense? Now, what we want to do is just hyperbolize the difference. One grows by 50, one grows by 40, which is not that big of an amount, right? We're going to make it big on the graph so we can see the change. Make sense? So it said we're 50% of good X and 40 of good Y. So we got better here and only a little better here. You guys see how that's like the new PPF? I hyperbolize it so you can see the difference. I don't want to measure it and make it slightly tilted. We're all good? So what did the curve be? Oh wait, my X and Y's are backwards, aren't they? Oops, hold on. I can fix that. Okay. That's Y, that's X. We'll start with a straight line, except we got better at what? X more than Y. So I'll make a big increase of X and a small increase of Y. Meaning, what did the curve become? Not steeper, but flatter. Well, I'm using straight lines, and that's going to simplify things a bunch for us. Because does it say there's specialization? No. So we can just use a straight line, and the theory will still work out. You guys following along with what I've done? We're increasing both, but more X than Y. So if we do that, where are we? 35. Okay. We look at this and it says the slope of the production possibilities curve has increased and the opportunity cost of X has fallen. Yeah. Okay. So that's the right answer. You guys need me to explain it to you? All right. Here's what it means. Let's say we start off with X and Y being a 1-to-1 ratio. Make sense? So every time I make a Y, what do I give up? An X, and every time I make an X, I give up. You guys got it? We're gonna hyperbolize it. So I should increase it by only 10%, and you're like, let's do more, and I go, correct answer. So now, let's say that this becomes 5, and this becomes 2. Okay? Because is it asking for numbers or math at all? So do you see how I'm hyperbolizing just to see it, make it clear? So now, every time, instead of being 1-to-1, it's going to be a 5-to-2 ratio. So now, instead of 1-to-1, every time I make a good X, I give up how many Y's? 2. That's a ratio of 0.4%, or 0.4, sorry. So I'm giving up 0.4 Y's for every X. Y's have gotten what for me now? I'm giving up what? 1 or half a 1? Like, here, I'll make this 4 and we'll make the math a bit easier for you guys. So you guys see it's a 2-to-1 ratio now? So every time I make an x, I give up half a y. What's more expensive, giving up 1 full y or giving up half of a y? Half. You guys understand? You can think of it kind of money. I give up $1 every time I make x, now I give up 50 cents. X is now what? Cheaper or more expensive? Cheaper. By the way, flip side, y has become a lot more what? Expensive. I have to give up 2 x's for every y. Proportionality. Okay. Ask questions on this one. This is a question that shows up.
Did you see the answer was A?
It's A, right?
No, I just kidding.
Yes. Yes.
It is A?
What does the key say?
Oh, I don't know.
The slope is decreasing, right?
Okay, I just.
Oh, I see what happened. Hold on. The absolute value of the production possibilities.
Okay.
The absolute slope of it has decreased. Oh, and the opportunity cost of y has risen. Hold on. Give me a second. Okay, the slope is decreased. And the opportunity cost of y. Yeah, y is more expensive. Or x is what? Cheaper. Sorry. Both of those are true. Sorry, I got it wrong. C. Is it good? Flatter slope? Sorry, not steeper. Not bad. Is that good? Everyone thinks that. Okay. Good, good, good. Any other questions about it then? That's why, do you see how I just drew it way bigger than the change was, just to see what is happening? Put some numbers in there that don't really matter, just to see the idea. It's a tricky question, that's fair, okay? All right, ready to move on?
I'm sorry. I just don't understand how the opportunity cost of Y has risen. If it got, like, if less is made when,
Every time I make a y, remember, the cost of y is an x, okay? So now, every time I make a y, I have to give up how many x's?
Oh, okay.
2. I used to give up how many? 1. Ooh, that's a lot more expensive.
Wouldn't you have to give up 4 x's for every y?
No, it's a 2 to 4.
Oh.
So for every 2, it's 4, or 1 to 2.
Why is A not right?
So it says the absolute slope has increased. That'd be
Oh.
steeper, and truth be told, it's flatter, decreased. Yeah, so that's where I kind of went, wait. It's more negative. Not right.
So the production increasing is making it less expensive?
So it's not because it increases for both. It's because it's asymmetrical. We have a technology that makes X a lot easier to produce and Y a little bit. So one is getting a big boost and one's getting a smaller boost. So essentially, instead of getting like really wrapped up and trying to calculate the math, I hyperbolize it. I made that small 10%, like one's 40, one's 50, and I said that little gap between the two, I made it really big. So you can see the idea, because do we have to use any calculations at all? No, you just have to get the idea. So the fact that one's 50 and one's 40, all you really need to know is one is more, the other grew less. So the slope of the curve has changed, it's flatter, and that means the cost of each one has changed. That means the cost of an X is lower and the cost of making a Y is greater. Good. And it's like a long way, there's just no short way to sum it up. Better? It's tough, like, it's fair. If you're like, that one's a little rough, yeah, some are easy, some are not. All right, ready to move on? We'll go to, we start getting busy, 40. So, one parent picks up the child from daycare while the other parent goes to the grocery store and begins to make dinner. This cooperation with households, an example of this would be gains from trade, right? I do childcare, you do grocery shopping, your kid's taken care of, you know, I have a couple, and dinner's taken care of. Who wins? We all do. If one person tried to do it all, how well could they do both? Dinner would be ready way later and maybe be too rushed. So gains from trade. When we all specialize, we all benefit. Sound good? We're going to be getting into that pretty hard. By the way, when countries trade, who wins in free trade? Everyone. That's a key one. There's still a lot of people like, nah, tariffs are great and you can't trade, you should make it all yourself. And that is not aligned with really any economic theory. Okay? You might say, but a politician said, yeah, they say that a lot. They don't get it. They're protecting special interests and not the economy as a whole. All right, we all good? Let's move on now to 42. In 1 hour, the United States can produce 25 tons of steel or 250 automobiles. In 1 hour, Japan can make 30 tons of steel and 275 automobiles. This information implies that, all right, absolute advantage and comparative advantage, okay? What I'd recommend, and we're gonna show examples where we have tables, and we'll show examples where we have graphs. So I'm gonna take a moment right now and cover both those concepts with everyone so that you guys can kind of like, hopefully answer the rest of them better. And then tomorrow in class, you can ask the questions. I'll kind of dive right into the hard ones. Sound good? All right, how many of you guys watched the videos I posted or one set? Okay, that's gonna help a bunch. So real quick, definition of absolute advantage is whoever can produce more of the good with the given resources, okay? So what I like to do here is I'm gonna go ahead and make a table. So I go ahead and say, all right, I've got a table. We'll make one of these USA and the other Japan. All right, and then we're making steel and autos. All right. So, for United States, how much steel does United States make? 25 tons. How much does Japan make? So, absolute advantage just goes to whoever makes the most of the good. Who has the absolute advantage in steel?
Japan.
Why? They make more. There it is. Hard stuff, right? Everyone loves absolute advantage questions. But I've got bad news for you. How often are you going to be asked absolute advantage questions? Not that often. They are very easy. All right, let's go to autos. How many cars does Japan make? And how many cars does US make? Hold on, let me do that one a little better, and we'll do the whole thing, and we'll do it all the right way. Who has the absolute advantage in making cars? So Japan is better at both, okay? So there's kind of a series of like 7 questions you need to be able to answer for any comparative and absolute advantage. If you can answer them, every question's cake. And it's who has the absolute advantage in one good, who has the absolute advantage in the other. Next is who has the comparative advantage in a good, who has the comparative advantage in the other. Okay, so that's your top 4. They'll then ask, should the 2 countries trade? And 9 times out of 9, the answer is yes. Yes. There's a way it's not necessarily beneficial to trade, and those are dumb questions. So, yes. Then they'll say, what should each country specialize in? The answer is whatever their comparative advantage is. And they could ask, what is a good trade ratio? And that is where you guys go, oh no. But how many trade ratio questions will you see on pretty much any exam? 1 to 2. So if you can get through this whole thing and you're like, trade ratios got me stuck, that's okay. Just maybe 1 question you miss. That's like worst case. Sound good? I'll show you how to do trade ratios. So let's do this. What you need to do is, we found absolute advantage. Do I need to explain that anymore? Okay? Hey, Comparative advantage though, who can define comparative advantage?
In this case, it'd be the country with the lowest opportunity costs.
In every case, the answer to comparative advantage goes to the country or economy or person who produces something at the lowest cost. If you can produce something at a lower cost, that means you are more what in producing it? Therefore, what should you do? Produce that good and trade for the other. We're all down with that then? That's your key concept here, is that answers almost every one of those questions except for the what's a good trade ratio. That you have to do math. But we're gonna do it the math way. I'll give you guys like the 30-second way to solve these, which probably like 4 out of 5 times you can solve this thing in 30 seconds. Almost every single one of those questions except the last one, 30 seconds and you're done. Sound good? But let's do it the right way. So if you're like, I don't trust the 30-second way, cool, do it the right way with math. You guys ready? So here's what it means. First, we have to understand, what does it cost the United States to make a ton of steel? Well, the cost will be in the form of what? What? Automobiles. So how many automobiles do I have to give up for a ton of steel? So what I'll go ahead and do is I would love to write cost of one steel. Okay? You guys understand? I'm gonna put it down here. So I'm trying to find the cost of steel in the form of automobiles. So I need a ratio, which means I gotta turn those numbers into a fraction or a division problem. It's the same thing. You guys understand? But how do I set it up? Do I put 25 over 250 or 250 over 25?
250 over 25.
Outstanding. Okay, so some of you guys apparently are just good at math and get the concept. Good job. Some of you guys might be like me, who just goes, I don't want to take the time to like logically put it out. So guys, ready for your quick cheat? If you're like mnemonics? If we're trying to find the cost of 1 unit of steel, well then what's our base measure that we're trying to solve for? We're trying to find the price of steel. That means steel is our base. Where do you put the base of something? So where are you going to put 250 then? You guys got it? So that's just your like, I'm selling for 1 steel. That's my base. Bases go on the bottom. Good enough? So we go 25 on the bottom, 250 on the top, and that equals what? 10 autos. Does that make sense? So every ton of steel, US has to give up what? 10 cars. And what do we do over here? If you want to do it right, you put cost of 1 auto. And what do you do to that fraction? Yeah, we're trying to find the cost of an auto. That's our base. It goes on the bottom. You flip the fraction, so it will be 0.1 steel. You guys got it? Cool, I did it for that country. What do we now have to do? Since it's comparative advantage, we need something to compare it to. Okay, cool. So let's go ahead and do it for Japan. So we'll put cost of 1 steel, and we have 30, and we put 275. Which one goes on the bottom? Because that's our base. So we put 30, and what do we put on top? And that equals what? Ooh, that's a good one. So
9-ish?
Yeah,
9-ish.
Yeah, like 9 with like point something.
Like 9.16 repeating.
Okay, so, oh, would you use your phone? So you can use a calculator, or you can just do what? 30 into 275. We go up here, we're gonna move the decimal over, so we get rid of 3. 3 goes into 27 how many times?
9.
Oh, 9, sorry.
9!
Sorry.
Okay, and we have no remainder. 3 goes into 5 how many times? Once. With a remainder of 2. We have a 0, we bring it down. 3 goes into 20 how many times? 6. 6 times 3 is 18. 18 minus 20 is 2. So we know we're going to have 2 repeating, so we can do that. Is that good enough, guys? So we say the answer is 9.16 repeating. And then over here, we flip it. Ooh, it's not the eraser I wanted, but okay. All right, so we go over here and we'll have 30 over 275. Guys, need me to show you how to divide again? So what's the answer? You can't leave it as a fraction. Why? Trust me. It's also not an answer they'll give you. What'd you get?
0.10909091.
Okay, so we can go with that. 0.109?
What?
0.109?
Yes.
Boy, did they make this question hard. Okay, by the way, the AP exam makes the math even easier than this. And is this math actually hard? Did I hear a yeah? Man, I'm gonna. Ugh, don't worry, I'll get the 4th grade tutor to come in and help you guys with this whole division thing. Remember, what can you have?
A calculator.
So, 4-function calculator. All right, you guys got it?
Yes.
All right, now that we have our math done, and it's going to make the rest of this question, well, this question is essentially almost done. Now you need to find the comparative advantage. Comparative advantage, again, what's that definition?
They can produce the product for less money.
Not less money, because where's money? Is there any money up here at all? No. Produce it at a lowest opportunity cost. So the cost of steel is in the form of, and the cost of cars is in the form of tons of steel. So we've already done the math. This is easy. One steel cost us 10 in the US, but 9.16. Which one has a higher cost? Who has a lower cost? So who has a comparative advantage in steel? Correct. Japan does. This makes life really easy because who then must have the comparative advantage in cars? Now it's 0.1 versus 0.11 if we want to round. 0.11 is higher than 0.1. There it is. These numbers are so close, you'll never see numbers as close on Apex or College Board. So does that make you feel slightly better? Yeah.
Are they gonna be that close on like the test?
I've never seen it that close besides here. Like, but again, the math. If it's this close or this close, that's it. So you guys got it? So, and by the way, if one country has a comparative advantage in one good, by the law of math, the other country must what? Have a comparative advantage in the other. Ooh, that can kind of make it easy because I really need to solve for one and not necessarily the other. I'll show you when we get to the 30-second solution. This one, you'd have to do the math. It's far too close for you to just 30-second it. Do you guys got it so far? So, should they trade?
Yes.
Yes, always the answer. What should Japan specialize in? And they should trade for? What should the United States specialize in? And trade with Japan for? Guys feel good? I'm going to avoid the what's a good trade ratio because these numbers are way too close. Does that help? You feel better? Okay, good. Are we all set? By the way, the root one for a trade ratio is find a number in between the whole numbers. So 9.5 to 1 would be a good trade ratio. And you're like, that sucks. And I go, correct. Or 18 to 2 would actually work. But let me find better numbers for you. So what's the correct answer for 42 now? All right. The United States has a comparative advantage in automobiles. So I just did all the options. So if you get a question, they can ask it a bunch of ways. And you're like, I know how to do this. Guys feeling better about comparative and absolute advantage? We'll do them much faster from now on. Okay, so the next one here is 45. If the opportunity cost of manufacturing machinery is higher in the United States than Britain, and the opportunity cost of manufacturing sweaters is lower in the United States than Britain, then the United States will, well, if it's more expensive to make machines in the US, it means that it must be what in Britain? So Britain has the what in machinery? Therefore, they should, well, specialize in making machinery and then trade for the US, who has a lower cost. So who has the comparative advantage in sweaters? US should then do what? Specialize in sweaters and trade Britain for machinery. Yeah, we're getting there. All right. Yeah, sorry, that was an odd question. Does this make sense to everyone? You guys like see it?
Yeah.
All right, and therefore it says, what should they do? Then the United States will
Export sweaters.
export sweaters,
Import machinery.
import machinery.
C.
Yeah.
Sorry.
Yeah, see, good. Yeah, that's correct. Is that easy enough? That one just words. All right, ready for 49? All right, France and England both produce wine and cloth under conditions of constant opportunity cost. That means it has a PPF that are straight lines. And do you guys know why we use straight lines for all these and not bowed out curves like a real one would be? Makes the math easy. That's it. Will we ever have bowed out curves with opportunity cost? Or I'm sorry, with comparative and absolute advantage? Why? It will require calculus. Straight lines, there we go. All right, feeling good. So it says constant opportunity cost, straight lines. That means whatever the ratio is the ratio the whole way. So France can make 150 units of wine if it produces no cloth, and 100 units of cloth if it produces wine. That's your ratio. You guys understand? It's just like the Japan one and cars in the US. England can produce 50 units of wine, it makes no cloth, and 150 units of cloth to produce no wine. You guys got it? When international trade takes place, each country specializes in the production of a good in which it has a comparative advantage, 1 unit of wine exchange for 1 unit of cloth, and France exports 50 units of wine. We include that France produces blank units of wine, blank units of cloth, and then, okay. This one's easy, and then kind of sussing out the answer becomes a bit harder. Okay? What's sus? Do you guys know what sus means?
Suspicious.
No. Sus means to solve. Wait, do you guys not know that? Would you like me to get the dictionary? It's in it. Your form of sus is not. Yeah. But you guys, that is what sus means. So suss it out, we need to solve, investigate. Okay, ready? Let's go ahead and make that table really quick. And I think we'll kind of see how just framing this question gets us to an answer. By the way, are we going to have to divide, necessarily do that? I'll show you. The answer should be yes. We should always do it the right way with math, right? Do you have to? No. Okay. So let's go ahead and do that. So we have here, we have UK and France. We have wine and cloth. Guys got it? How much wine can the UK make? 50? And how much cloth?
150.
150. All right, France on the other hand, how much wine can they make? 150. And how much cloth?
100.
Okay. All right, remember that whole absolute advantage, comparative advantage thing? Let's make this thing simple. Who has the absolute advantage in wine? Who has the absolute advantage in cloth? Oh, notice how it's a different absolute advantage? If that ever happens, it usually doesn't, but if it does, that's also who has a comparative advantage. Done. It's not asking, it is asking for a trade ratio, except it actually already gives you one. We'll get into trade ratios later. I don't need to spend time on this, but it means UK will specialize in cloth, France in wine. And what's the trade ratio? It already says 1 unit of wine for 1 cloth. Everyone's on board? I'll tell you right now, it's a good trade ratio. So we can conclude that France produces how much wine? Well, it said France exports 50 units of wine. What is France going to do?
350 units.
How many units of wine will France produce total?
150.
150, because if you're rational, what's France going to do with all their production? Just wine. What is UK going to do with all their production? Specialize in cloth. You guys understand? So France will make how much wine? 150. And how many units of cloth? 0. You guys got it? Specialize in what you're best at. Do only that. Trade. Okay, good? But next, it says, and France consumes how much wine? How much wine can France consume now? 100. How do you know?
150 minus the 50.
Yeah, they exported 50. So can you consume something you exported? No, you cannot. So they export 50 units. So they can consume how much wine?
100.
And how much cloth?
0.
Hmm?
50.
They exported 50 units of wine. That means they received how much cloth?
50.
Do you guys see it now? So it's find out what they're best at. And then, I mean, it even tells you France exporting wine. There it is. You just got to know your ratios and math. Easy enough? Any questions? All right. Let's dig into the last few. So we really get into the comparative and absolute advantage. We're going to be a lot faster because we feel a little bit better about it. All right, so let's get into this one. Do you guys notice how we had tables the whole time?
Yeah.
Well, here's a graph. Except all you really need is an Alpha Land. They make radios and tires. So if we made that and put Alpha Land, Omega Land, we just make a table with radios and tires. What would we put for Alpha Land for radios? And what would we put for tires? What about radios for Omega Land? And 800 tires. Easy enough, guys? If you're not sure, you don't like the graph, what should you just convert this whole thing into? A table. Tables can be graphed, graphs can be tabled. Easy enough? Don't say, oh, one's the easy one, one's the hard. Now just convert. Okay? So, if Alpha Land specializes in the production of the good, it's comparative advantage. All right, without tabling it, let's go ahead and just solve with what we know. Okay? Who has the absolute advantage in radios? Omega Land does, because they do 1600 versus 600. Who has the absolute advantage in tires? Oh wait, if you have differing absolute advantages, what does that mean?
They should say.
That's their comparative advantages too. Done. Math achieved. Okay? So, Alpha Land's only making tires, Omega Land only radios. Got it? So if Alpha Land specializes in production of goods as comparative advantage, Alpha Land will make how many tires? Yeah, completely specialized is your best bet. There it is. Answer. Okay? Guys feeling good? That one's all set? All right. You guys didn't need 51. You guys wanted 52. All right, another one like this, and oh my gosh, it's like the same one. All right, in the figure, blank has the absolute advantage in the production of blank and a comparative advantage in the production of blank. Well, who has the absolute advantage in computers? The US? Who has the absolute advantage in roses? All right, they have differing absolute advantages. That's also their comparative advantage. So you need something that says, in the figure, the United States has the absolute advantage in the production of computers and a comparative advantage in computers. So United States computers roses, United States roses computers. Is that our answer? Okay, one of our options can then be Colombia has the absolute advantage in roses and the comparative advantage in roses. Those are the only two right answers. The US one is not it, so we go Columbia Computers Roses, Columbia Roses Roses. That's your answer. You guys finding it out? All right, let's move on then to 53. All right, this is one of the tables that confuse people, but it's really simple. When you see the zeros here, could you, in theory, just ignore them? Yeah, that's it. Like they're just kind of there to be like, but a zero. You're either making all of one, all of the other, or a mix. Oh my gosh, it's so easy. According to data, the opportunity cost of one computer is, you know what we're gonna have to do if they want to know the cost of producing something? Math. Yeah, I know, it's gonna be super hard. Okay, the opportunity cost of one computer is blank for blank. So US and Columbia, we have to solve for both, but we only need to solve the computer one. Okay, so we want to find the cost of one computer. Sound good? So we have 2,000 computers and 1,000 roses in the US. What goes on the bottom? Solving for computers, that's our base. So we put 1,000 over 2,000, and it's what? Yeah, or 0.5 roses. Easy enough? But let's go ahead and do this for Columbia. Okay, so we go cost of one computer is, well, we have 1,000. What do we put on, and 2,000? What goes on the top? 2,000. 2,000 over 1,000 is 2 roses. Who makes a cheaper computer? Therefore, the United States has the what in computers? There it is. So the United States has a comparative advantage. So let's say United States, it should be, the opportunity cost of one computer is half a rose. Yeah. So United States, half a rose, 1,000. Is it the United States an option? It's got to be a Columbia option. Columbia, it's 2 roses. So Columbia, 2 boxes of roses. B. Little bit of math. How hard was that math? That's the right difficulty of math. Okay, calculator necessary? Okay. Do you guys feel good about 53 then? All right, let's move on. Last one, 54. All right, same structure. Let's see what it wants. The table shows the production possibilities for both the United States and Canada. Okay, both nations produce cars and lumber. Okay. If these nations were specialized in trade, which of one potential agreement would benefit both? This one's asking for a trade agreement. It's going to require math. Okay? So we're going to do all the math out and I'll show you how to find a trade agreement ratio. Sound good? Now, you might already be able to do the absolute comparative advantage, but we actually, when it wants a trade ratio, you really want to do the math. So, ready to buckle up and do the math? And you're probably already looking going, this math is not very hard, right? All right, so let's go ahead. We'll do it for the United States and then we'll do it for Canada. All right, so the United States, we'll put cost of one lumber. All right, which number goes on the bottom? Good, lumber. Yeah, oh, okay, that's a good one. Or what number though? And what goes on top? Which is what? Very good. All right, so what's the cost then of one car? One lumber. Very good, whoever said one lumber. That is the way to think of it. All right, gosh, math is hard, guys. Whew-wee. Right? All right, ready for the next one? Canada, on the other hand, it's a bit different. So we'll go cost of one lumber. What number goes on the bottom?
12.
What goes on top?
2.
What number is that?
16.
16. 16 is what number? Oh, okay. 0.18 And go to two decimal places, always enough. You guys got it? All right, let's flip it and put of one car. 12 over 2 is what? 6 lumbers. And this should be cars. All right, all good? So now, here's how you find a trade ratio. First off, who has the comparative advantage in producing cars? Ooh, take a second. You need to be able to answer this. Who has the comparative advantage? How do you know? What's the definition of comparative advantage? Whoever produces it at the lowest opportunity cost. The cost is in lumber. Who gives up less lumber per car? Because 1 is less than 6. Yeah, I know. Complicated math. I know. I'm teaching you like values. Okay. You guys got it? All right. Who has a comparative advantage in producing lumber? How do you know? 0.18 is less than 1. Easy enough, guys? Okay, with that being said, let's get into what is a good trade ratio. I'll give you a quick cheat code, but just remember, when you think of a number, does that mean it's the only ratio that'll work? No, there are many that'll work, but the answer is this. First, go into your whole numbers. Typically, you'll have one set of numbers that are whole numbers, the others that are decimals. Easy enough? What's easier to work with in fraction-wise, whole numbers or decimals? Yes, whole numbers. And find a ratio in between the two. So where are whole numbers? 6 and 1. Pick a number between 6 and 1. 4. 4 to 1. Is 4 to 1 in between 6 and 1? Would 1 to 2 work? 1 to 3, 1 to 4, 1 to 5. What about 2 to 7? Yes. 2 to 7 is 3.5. Is 3.5 between 1 and 6? All of those are right answers. If it's multiple choice, you don't get to come up with your own. You have to find the one that they thought of. So, do you guys understand? And when I say let's think of 1 to 4. That's 1 what for 4 whats? That's going to be, this is always where like you have to take a moment. So that's going to be, hold on, I always have a trouble. Yeah, so that's going to be 1 car for 4 lumbers. How do you know? Which is the big number? Lumbers. Okay? You guys got it? So we find a number that's in between. All good? So we look at this, and okay, we can't see it all. 1 million cars for 12 million. Is 1 to 12 in between 1 to 6? No. 1 to a half. No. 1 to 8. Okay, and just because you guys can't see it here, we'll get rid of this. We already know what we're looking for. 1 to 1? No, they could do that on their own. They don't need to trade. That would be okay, but just okay. We're just as good as if we didn't trade. And what about 1 to 2? But could 1 to 3 be right? 1 to 4, 1 to 5, 1 to 5.5 is fine. So does everyone understand? All right. I'm going to give you guys one quick thing here. When we're looking at a question kind of like this, the 30-second way of solving comparative and absolute advantage. Absolute advantage should take you how long to figure out the absolute advantage between two countries? Couple seconds, right? Comparative advantage, though, is this. Comparative advantage is whoever produces the good at the lowest cost. So again, doing the math is always the right way. But if you want to hurry and you can see it also means everyone should do what they're best at. So if I'm better at one thing and I'm better at the other, do I have comparative advantage in both goods? Never. I have the absolute in both. Always the ratio will be different. You can't flip fractions and be higher in both ends. That's just not how math works. So what you can do is, if I'm better at one thing, like I'm a little bit better than you at one, but way better at the other, should I do good A or good B? B. And if I should do good B, what should you then do? A. And if we trade, we'll both be better off. So you guys understand, when you see someone, because most questions, I'm telling you now, most of them have a absolute advantage goes to, both absolute advantages go to one country, okay? All you really need to do, and this works for most of them, probably like 4 out of 5, is, yeah, but which one are they best at? They should do that. The other country does the other one. That's their comparative advantage. Easy enough? So we'll work on it. We'll try to go through it quick in class, and then we'll focus on you guys finding that trade balance. Sound good? All right, guys, that is it, and I'll see you guys at the quiz.